Okay, today we're going to start chapter 6. We're looking at graphing systems of equations. We have already talked how to graph equations, right? We did it a lot. Even last chapter, we did it with inequalities. It's the same idea with an equation. You just don't have to shade. You also don't have to worry about solid and dotted lines, right? So really, it's easier than the graphing that we did last chapter. The difference is, instead of graphing one equation, you're graphing two on the same graph, okay? So, first thing we're going to look at is just how to identify your answer based off what graph you get. Okay, so you might want to write these down. See if I can do this right. Oh man, hold on. Okay, so these are the three possible ways your graph could look. All right, so there's three different answers. You could get one solution, you could get infinitely many, or you could get no solution. Does anyone think they can identify any of those three? Cage.
The infinite one is one on the left.
The one on the left is which one? No.
The right one.
The right one is no solution.
Infinite? Yeah, that's what I said first. I just went to the left.
Okay, why would it be no solution here? Because the two lines never cross. Why would the middle one be infinitely many?
Because they keep going infinitely.
Say it again, Grayson. Yeah, those are, it looks like one line, but they're two. Because remember we said we're graphing two different equations, but if they're the exact same equation, they're going to touch at every single point. So it would be basically all reals or infinitely many. If I can spell today. Yes, you do have to write infinitely many.
What's the other one out of the three?
What would this one be? One solution. When you get one solution, you have to tell what it is. Can anyone tell me what that one solution is?
It's the one where they cross.
3, 2, 2.
Yeah, really, it's kind of, this one's kind of at 2.5, 2.5. Okay. So, one solution, the two lines will always cross. They will meet at one point. You need to say what that ordered pair is. Infinitely many, you'll know before you graph because you're going to get the same equation, right? Your two equations will look exactly the same. Can anyone tell me how you would know before you graph if you would get no solution? We talked about this 2 sections ago. How do you know based off an equation if two lines will never cross?
If your y-intercept is negative, right?
Nope. Rylan?
It's the negative inverse.
Nope.
If your slopes are the same.
If your slope is the same. Good. Remember we talked about parallel lines have same slope. Now, all of the other ones, they may not have a perpendicular lines would be the opposite reciprocal, right? But you will know, honestly, you should know what your answer is before you ever graph, okay? Because if they're the exact same, it should be infinitely many. If you have the same slope, it's going to be no solution. Otherwise, it's going to be one solution every time, okay? First thing I want you to do is open your book to page, I think, 336.
300.
I should have. Let me see if I can pull this up real quick so you can show it on here. Yeah, you do need to.
Need to or
Have to.
What are we doing?
I think it's 336.
Shouldn't it just be in your bag? Is your bag? Is your books on just in your bag? Go back to the
Okay, let's go to 338. Okay. I'm going to take a picture and I'll pull this into our notes so you can kind of look at it there too, but it might be easier for you to see on your paper, yeah, than it will be on here. But I'll try to pull it up so if anybody's watching, they can see it as well. Okay. All right. So the directions say use the graph at the right to determine whether each system is consistent or inconsistent. We're not worried about that. We're not worrying about independent or dependent. All I want you to do is look at the graph and tell the number of solutions. Okay. So we're going to look at number one. Number one, what are the two equations it gives you?
Y equals negative 3x plus 1, and y equals 3x plus 1.
Okay, so on those graphs, they have color coordinated them for you. So what color is negative 3x plus 1? Blue, right? So we're looking at this one here. What color is 3x plus 1? Red. So these are the two lines we're looking at. What would you get as your answer? One solution, no solution, or infinitely many? Nick? One solution. What is that one solution?
1.
Yeah. So our answer would be one solution and the ordered pair 0, 1. Okay. All right. We're going to look at number 3 next. What are the two equations it gives you on number 3? Okay, what color is y equals x minus 3? Green. What color is y equals x plus 3? Purple. Now again, you should know before even looking at those graphs because they have the same what? Slope. Same slope means what? No solution. Okay. All right, last two on this. We're going to look at number 5. Okay, now, what are you going to have to do to x minus y is equal to negative 3? Yeah, you're going to have to change it into slope-intercept form. Now, sometimes you guys, you should always look first because sometimes they won't even change it for you. They'll just have the equation pointing to a line. Okay, so can anybody change that for me? Come on. Okay. That would give you negative y is equal to negative x minus 3 divided by negative 1. So you would get y equals x plus 3. Okay? Which line is y equals x plus 3? Purple. Okay? Which line is y equals negative 3x plus 1? Blue. Okay? What would be my answer here? What is that one solution?
Negative 1/2, and then like 2.5.
Good. Okay. So these types of questions are easy because they've already done the graph for you. You just look at the two graphs, one solution, no solution, infinitely many. Yes?
Yes.
Questions?
No.
Okay, let's graph our own. We're going to do y is equal to negative 3. Y is equal to x minus 3. Okay, can anyone tell me how you would graph y is equal to negative 3? We've talked about it briefly before. What type of line is it going to be? No, that's only for inequalities. You are going to go down 3, and then which direction is that line going to go? It'll only go through, yeah, goes through the y-axis at negative 3. Remember, x equal to a number would go through the x-axis only at that point. So it, like x equals negative 3 would be a vertical line. Y is equal to negative 3 is horizontal. Okay? All right, can somebody else tell me how would I graph y equals x minus 3?
Go down 3.
Good. We're going to go down 3 and put our point. Then what, Nick? Or Cage?
Go up 1, right 1.
Why do you go up 1, right 1?
Because it's positive 1 over 1.
Yeah, because your slope, right? The value in front of x is 1 over 1. Okay. All right.
One
So,
solution,
I get one solution
0, -3.
at 0, -3. Okay. Yes.
How do you get the point for the line solution? Like, how do you get the 0, -3?
Where the two lines meet.
Oh, okay.
Yeah. The point where the two lines intersect. Good question. Yeah, if they meet, you're looking where that ordered pair where the two lines are intersecting. Okay? All right, let's look at y is equal to x minus 6 and y is equal to x plus 2. How do you know it's no solution, Reno? Yeah, they have the same slope, okay? So, we know already our answer is going to be no solution, but we're going to graph and check it anyway, okay? Reno, how would I graph the first one?
Go down 6. And then up 1, right 1.
Okay, I go down 6y, because that's my what?
It's your y-intercept.
My y-intercept is -6, okay? And then I go up 1 over 1 because of my slope. Okay, these, I'm going to say you should be pickier on your lines, especially the ones that cross, because if you're not careful, like most of you should have a ruler because you got one at the beginning of the year, I'd suggest using it, especially if they're going to cross. Okay? All right. Marley, can you tell me how to graph the second one?
Go up to your point,
Okay.
up 1 over 1. Up 1 over 1.
Right? So we do get no solution because the two lines never cross because they are parallel, which we know because of the slope. Yes?
Do I still have to graph it, even though we know it's not?
Oh, yeah. Because that way you'll know how to graph.
Where do you know how to graph?
Well,
We've done this like 1
some. That's good. It won't help you. It won't hurt you to practice it.
It might make you that grade because you're taking your time.
I doubt that. Okay. Molly, what do I need to do to that top equation before I can graph it? Perfect. Do that for me. Okay, I would get negative y is equal to negative x minus 2. What would that give you? Good. And Alyssa, what about the next one? What do I need to do to that? Okay, what would you get? Okay. What do you know about your answer? Yeah, how do we already know it's infinitely many? Yeah, because you got the exact same equation, okay? Now, this one's easy to graph because you only have to graph one of them, right? Doesn't make sense to graph the other one because you're going to graph the same thing. So, Taya, how would I graph that equation?
You would go up 2
Good.
and then up 1 over 1.
Yep. Perfect. Okay.
And then go up.
Do I have to do it again?
No.
No, right? Because again, it's just going to be the same equation. Do what?
There's only one.
There is though.
Yeah.
Oh.
No, you only did one.
Oh, there's two.
Just draw it to one side of it, just
Okay.
to make sure.
I'll tell you what, Cage, Grayson, Reno, all three of you can draw 2 lines on yours.
Okay.
Okay, how do we feel about this? Here's what I'm talking about, you guys. A lot of the stuff we do just take stuff you already know and it's just kind of like adding little steps to it. Okay? will be a worksheet today. I'm just going to write this, that way people online. On our worksheet, we're doing all problems. I think it's 1 through 13.